Hi all, now we can study generalized error coefficient. It is also known as dynamic error coefficient. In the previous class, we studied static error coefficient. In that case, the input must be or the input should be step, ramp or parabolic. But the drawback is that it does not show the variation of error with time. Also, input should be a standard input, step, ramp or parabolic. So the generalized error coefficient gives the steady state error as a function of time. Also, the steady state error can be found for any type of input. So, the error signal in S domain E of S can be expressed as product of two S domain functions. We know E of S is equal to R of S divided by 1 plus GSHS. That's equal to 1 divided by 1 plus GSHS into R of S. That's equal to F of S R of S, where F of S is equal to 1 divided by 1 plus G of S H of S. So remember this expression. We need this expression while doing problem. Now E of S is equal to R of S F of S. Error E of t is equal to inverse Laplace transform of this. Now by convolution, E of t is equal to inverse Laplace transform of F of S R of S. So integral with the limits 0 to t f tau r t minus tau d tau, that's equal to f convolution r. Now rt minus tau, it can be expressed in Taylor series. So rt minus tau is equal to r of t minus tau r dash t plus tau square by 2 factorial r2 dash t minus etc. So E of t is equal to integral with the limit 0 to t f tau. Instead of for this rt minus tau, write this Taylor series. Now take the limit as t tends to infinity in order to get steady state error. Limit t tends to infinity 0 to integral with the limit 0 to t f tau into r of t minus tau r dash t etc. d tau. So applying the limit as t tends to infinity 0 to infinity. So the limits is changed from 0 to t to 0 to infinity. T tends to infinity. And after removing the bracket f tau rt d tau minus integral with the limit 0 to infinity f tau r dash t d tau plus etc. This is equal to C0 R of t plus C1 R dash t plus C2 R2 dash t divided by 2 factorial plus etc. Where C0, C1, C2 up to Cn, they are known as generalized error coefficient or dynamic error coefficients. Where C0 is equal to integral with the limit 0 to infinity f tau d tau. R of t is here. Similarly, C1 is equal to minus 1. Here there is a minus sign. So put minus 1 integral 0 to infinity tau f tau d tau. This r dash t here. Then C2 is equal to minus 1 the whole square. Here it is plus. So in order to put in a general form, write minus 1 the whole square integral with the limit 0 to infinity tau square f tau d tau 2 factorial and r2 dash t here. So in general Cn is equal to minus 1 raised to n integral with the limit 0 to infinity tau raised to n f tau d tau. Now the evaluation of this generalized error coefficient. How will you find this C0, C1, C2, etc. Now Laplace transform of f tau from the basic definition, that is equal to f of s, that is equal to integral with the limit 0 to infinity f tau e raised to minus s2 d tau. Take the limit as s tends to 0. So limit s tends to 0, f of s is equal to limit s tends to 0 integral 0 to infinity f tau e raised to minus s2 d tau. That's equal to, applying the limit as s tends to 0, e raised to minus s2 it is equal to 1, therefore it's equal to 0 to infinity f dot d dot, that's equal to c0. That is, c0 is equal to limit s tends to 0 f of s. c0 is equal to limit s tends to 0 f of s. F of s is equal to 1 divided by 1 plus gs hs. Now differentiate this expression with respect to x. So d of f of s divided by ds is equal to minus 1 integral with the limit 0 to infinity e raised to minus s2. So tau minus is here, f tau e raised to minus s tau d tau. Now take the limit as s tends to 0. S tends to 0, limit s tends to 0, df of s divided by ds is equal to limit s tends to 0. Integral minus 1 is there, 0 to infinity tau f tau e raised to minus s tau d tau. Then apply the limit as s tends to 0. So this term will be is equal to 1. So this is a minus 1 integral with the limit 0 to infinity tau f tau d tau. That's equal to c1 from the previous slide. Therefore, c1 is equal to limit s tends to 0 d f of s by ds. Similarly, c2 is equal to limit s tends to 0 d square f of s by ds square. So up to cn is equal to limit s tends to 0 d raised to n f of s by ds raised to n. So remember this. Again, it is required while doing problem. Now there is a correlation between static and dynamic error coefficients. The following expressions show the relationship between static and dynamic error coefficient. C0 is equal to 1 by 1 plus Kp, C1 is equal to 1 by Kv, C2 is equal to 1 by K. That is, we can prove that C0 is equal to limit s tends to 0 f of s. That's equal to limit s tends to 0, 1 divided by 1 plus gs hs. That's equal to 1 divided by 1 plus limit s tends to 0 g of s h of s. That's equal to 1 by 1 plus kp. By definition, kp is equal to this. So that's the correlation. Now we can do one problem. For a unity feedback control system, the open loop transfer function g of s is equal to 10 into s plus 2 divided by s square into s plus 1. Find the steady state error when the input is r of s, where r of s is equal to 3 by s minus 2 by s square plus 1 by 3 s cube. So step, ramp and parabolic. Steady state error is given by C0 r of t plus C1 r dash t plus C2 r2 dash t, etc. Given that r of s is equal to this expression. So r of t, we must have C0 r of t. So find r of t. That's equal to 3 minus 2t plus 1 by 3 into t square by 2 factorial. Take the inverse. So 3 minus 2t plus t square by 6 r dash t minus 2 plus 1 by 6 into 2t, that's equal to minus 2 plus t by 3 r2 dash t, that is equal to 1 by 3 and r triple dot t, that's equal to 0 because this is constant. So our equation is reduced to steady state ESST is equal to C0 r of t plus C1 r dash t plus C2 r2 dash t. Only this much. So our aim is to find the constants C0, C1 and C2. C0 is equal to limit s tends to 0 f of s. C1 is equal to limit s tends to 0 d by ds of f of s. C2 is equal to limit s tends to 0 d square f of s by ds square. Now f of s is equal to 1 by 1 plus gshs. That's equal to 1 by 1 plus gshs is this much. So simplify, you will get this expression. So C0 is equal to limit s tends to 0 f of s is equal to limit s tends to 0. That's equal to 0. Applying the limit as s tends to 0. F of s is this much. Similarly, C1. C1 is equal to limit s tends to 0 d by ds of f of s. So here we have to take the differential of this quotient, that is v into differential of the first minus u into differential of the second divided by v square. Apply the formula, simplify, and you will get C1 is equal to 0. Then C2 is equal to limit s tends to 0, d square by ds square, f of s is equal to, take that expression 20s cube plus, that is from this expression, again apply the this is again quotient. So again apply that particular formula, that is v into differential of the first minus first function into differential of the second divided by v square. So you will get C2 is equal to 1 by 10. Therefore, steady state error C0, C1, 0. So this is the so the answer is this two term will become 0. So 1 by 3 into 1 by 10 into 1 by 2 factor, that is equal to 1 by 60. That is the answer. Thank you.